Imagine an AI that doesn't just, process information, but truly thinks, like exploring dozens, maybe even hundreds of possibilities all at once, finding solutions to problems that totally stump human experts.
Yeah. It sounds like science fiction, but it's really happening now.
It is, and that's what this deep dive is all about. Google's Gemini 2.5 Deep Think, it really feels like a groundbreaking AI model.
Absolutely. Our mission today is to unpack its revolutionary parallel thinking mechanism. We'll look at its, well, frankly, astounding performance on some super tough tests,
Right.
its strategic position in the fast-moving AI world, and also the really crucial safety challenges it brings up.
Okay, so by the end of this, you listening should have a really clear idea of what makes this AI so different and, well, why it matters for the future of tech.
Exactly.
And our info today, it's coming from this pretty comprehensive report, Gemini Deep Think, Parallel Reasoning and Strategic Implications.
That's the one. It gives us a really exhaustive look into this powerful new system.
Okay, let's unpack this.
So the whole field of AI is really shifting quite significantly. We're moving beyond models that just, predict the next word or spot patterns.
Mm.
Now we're seeing this new class of what people are calling thinking models.
Mm.
They're designed specifically for complex reasoning.
So not just sorting data.
No, not just classifying data. It's about analyzing information, actually drawing logical conclusions, and making informed decisions. It's a different level.
Okay, so if I'm getting this right, Deep Think is fundamentally different from how AIs usually work, like that step-by-step chain of thought prompting we hear about.
Precisely. It departs from that linear processing. Instead, it uses this dynamic multi-hypothesis approach. It's designed to kind of emulate how humans solve complex problems.
How so? What does that look like in practice?
Well, it takes its time. It explores different angles, weighs up potential solutions, maybe combines ideas, and refines a final answer before it gives you the output.
So it's like it's brainstorming internally, considering lots of options at the same time.
Exactly. Rather than just marching down one single path.
And Google's clearly positioned this as, well, a very premium tool, haven't they? High-end stuff.
Oh, absolutely. It's an exclusive feature within the Gemini app, only for subscribers to the Google AI Ultra plan.
Which true.
It's $249.99 a month, a substantial cost, and you get a fixed number of prompts per day.
Wow. Okay, so definitely not for casual users.
Not at this stage, no. High-end tier for sure.
And there's also this dual release strategy, right? There's the super powerful research version, the one that won the Math Olympiad gold medal.
That's right. Available only to a select group of mathematicians.
And then there's the more, let's say, scalable version for the premium subscribers.
Yes, a day-to-day version, which raises that important question you touched on.
Yeah, what does this actually mean for accessibility? Who gets to use this kind of power?
Well, it means the absolute cutting-edge capability, the gold medal stuff, that remains highly constrained. The public version is, more practical for daily use, but it's less powerful.
So a trade-off.
It's a classic trade-off, yeah. Balancing that bleeding-edge research with broader usability and safety, frankly.
Okay, that makes sense. So Deep Think is about how the AI thinks internally. But I've also heard the name Gemini Deep Research. Is that connected? Or something else entirely?
That's a really good question. And yeah, the names are similar. It's easy to mix them up. Deep Think is about enhancing the model's internal cognitive process. It uses parallel thinking to improve how it reasons through a single complex prompt.
Okay, the internal mechanics.
Right. Gemini Deep Research, on the other hand, is what we call an agentic system.
Agentic, meaning?
Meaning it can act. Think of it like a super smart research assistant. It can define a plan, browse the web autonomously, pull information together, write code, run it. It manages a whole multi-step task.
So Deep Think is how it thinks. Deep Research is what it does, like planning and executing tasks.
You've got it. And this dual focus really shows Google's ambition, right? They want to lead in both the depth of AI thinking and the breadth of what AI can actually do autonomously.
Okay, so we've got this picture of thinking models, but let's dive back into that core idea, parallel thinking. Can you take us sort of under the hood? How does this actually work?
Right. Conceptually, the model generates a whole bunch of ideas or potential solution paths simultaneously.
Like loads of them.
Potentially dozens, even hundreds, according to some reports. It considers them all at the same time. It can even revise paths based on insights from other paths, or combine them, before it settles on a final answer.
Wow.
It's a really deliberate move away from that linear A then B then C reasoning One mathematician who used it said while he was thinking about maybe 3 approaches, the model seemed to be exploring 20 or 100 many different possibilities in parallel.
Good grief. It's like having a whole team of experts brainstorming inside the machine.
That's a good analogy, yeah. Bouncing ideas off each other in real time.
My brain hurts just thinking about tracking maybe 3 paths. That must be incredibly computationally intensive.
Oh, it absolutely is. And that's why Google explicitly calls it allocating thinking time to the model.
Thinking time.
Yeah. Developers using the API can even set a parameter called thinking budget in tokens. It basically tells the model how much computational effort to spend.
So you can control how deeply it thinks.
To an extent, yes. And for transparency, which is pretty neat, the API can give you thought summaries. These kind of synthesize the model's internal deliberations.
So you get a peek into its reasoning.
You do. It shows you the different paths it considered. It's quite a remarkable level of introspection for an AI.
Okay, so Deep Think is exploring potentially hundreds of paths using this thinking time. But how does it physically do that? What's the engineering underneath? Because it's not just clever software, right? There's hardware involved.
Exactly. It's built on a really sophisticated technical foundation.
Yeah.
The core architecture is a sparse mixture of experts,
Sure.
usually called MOE transformer.
MOE.
Yeah, mixture of experts. This design allows for absolutely immense scale, think trillions of parameters, while keeping the computational cost somewhat manageable.
How does it manage the cost?
Because for any given piece of input, only a small subset of expert networks within the larger model are activated. So you're not running the whole gigantic thing all the time.
Clever.
And this massive architecture runs on Google's own custom-designed chips, the tensor processing units, or TPUs.
Right, I've heard of those. Optimized for AI.
Exactly. They're built for the kind of large-scale matrix math that these models rely on. Training happens on huge clusters of these called TPU pods.
Pods, okay.
And they've built in this feature called slice granularity elasticity. It's a bit of a mouthful.
What's it mean?
It means the training process is incredibly resilient.
Yeah.
If some TPUs in this massive pod fail, which happens,
Right.
the whole training job doesn't just crash. It can seamlessly continue on the remaining hardware, which is absolutely critical when you're training models of this scale for weeks or months.
Wow. So the hardware is key, but just having the engine isn't enough. How does Deep Think actually learn to use this parallel thinking effectively to reason so deeply?
That's the other crucial piece. It's not just architecture. It's highly specialized training. Google used what they describe as novel reinforcement learning techniques.
Reinforcement learning. Okay, like learning from trial and error.
Sort of, but much more sophisticated here. These techniques can leverage data involving multi-step reasoning, complex problem solving, even mathematical theorem proving.
So it learns how to reason.
Exactly. It trains the model to productively use those extended thinking paths. How to identify which paths look promising, how to synthesize insights from different paths, and maybe crucially, how to prune the dead ends so it doesn't waste time.
Makes sense.
It helps the model become, as they put it, a better, more intuitive problem solver.
And was there specific data used for this?
Yes, they mentioned guiding the learning with a curated corpus of high-quality solutions to mathematics problems. This suggests it was rewarded for finding verifiably correct answers, especially in tough domains like math.
Okay, so if I'm piecing this together, massive MOE architecture, custom TPUs for power, specialized reinforcement learning to guide the search. It really sounds like a strategy of almost computational brute force.
That's a very apt way to put it.
Explore everything, filter intelligently. Is there downside to that, or is it just pure power?
It's definitely power. It lets it break through problems that were just intractable before.
Yeah.
But yeah, the downside, if you want to call it that, is the sheer cost and the enormous resources needed.
Right.
This combination, MOE, TPUs, the RL guidance,
Yeah.
it really is a different philosophy, less about finding one single elegant, clever path.
Moment.
Exactly. More about using immense computation to explore a combinatorial explosion of possibilities and then having smart ways to filter that down. It's a new way to think about discovery, enabled by scale.
Okay. Now, with all this talk of parallel, it's easy to get terms mixed up. Let's try and clarify a few things for listeners. First, deep think versus something called tree of thought, or TOT. They sound related.
They do sound similar, and it's a common point of confusion. Both explore multiple reasoning paths, that's true, but 2T is generally understood as a more structured, sequential search. It builds a branching tree of possibilities and explores them, often with explicit steps to evaluate nodes and backtrack if a path isn't working.
Okay, more a step-by-step exploration of branches.
Right. Deep Think, from what Google describes, seems to involve generating and considering these multiple ideas truly simultaneously. And that unique RL-driven synthesis step seems to be a key difference, maybe proprietary Google advancement. It feels more organic and parallel, less like a rigid tree search.
Got it. Next comparison. Parallel thinking versus parallel decoding, sometimes called speculative decoding. These sound almost identical.
Yeah, the names are confusingly close, but they serve totally different purposes. It's critical to get this straight.
Okay.
Parallel thinking, the deep think kind, is a reasoning enhancement. Its goal is to improve the quality, the depth, the creativity of the model's final answer. It often means more computation, more latency to get a better result.
Making it smarter.
Right. Parallel decoding, or speculative decoding, is purely a latency reduction technique, speeding things up.
Ow.
It usually uses a small, fast draft model to generate text quickly, and then a larger, more powerful target model verifies batches of those generated tokens in parallel. The aim is to get the exact same output as the large model would have produced, just much faster.
Ah, okay. So deep think, smarter, maybe slower. Speculative decoding, faster. Same output.
Precisely. One's about improving the thinking, the other's about improving the speed of generation. Totally different goals.
That's a really helpful distinction. Now, this brings up another question I know people have asked. Quantum computing. We hear about Google's quantum efforts, like the Willow chip, maybe links to many parallel universes. Is any of that related to deepthink?
Okay, let's be absolutely clear here. No. Research into Google's Willow quantum AI chip, or any quantum computing concepts, is entirely separate and technologically unrelated to Gemini Deep Think.
Completely different things.
Completely. Deep Think runs on classical computers, those TPUs we talked about. Quantum computing uses quantum mechanics, superposition, entanglement. It's a fundamentally different type of computation.
So the word parallel is just overloaded here. It means different things in different contexts.
Exactly. You have parallel processing in classical computing, which Deep Think uses massively.
Yeah.
You have the conceptual parallel thinking of the AI, and then you have the potential parallelism in quantum computing. They are not the same thing. Don't let the shared word mislead you.
Right. Important clarification. Okay, let's shift gears to performance. How good is this thing? The biggest headline seems to be the International Mathematical Olympiad, the IMO.
Yes, that was the landmark public demonstration. An advanced research-grade version of Deep Think achieved a gold medal standard at the 2025 IMO.
Gold medal. That's huge. How did it do?
It scored 35 out of a possible 42 points, correctly solving 5 out of the 6 incredibly difficult problems. And crucially, it did this end-to-end in natural language within the standard 4.5-hour exam time.
Unlike previous attempts.
Right. Previous AI systems tackling IMO problems often needed humans to translate the problems into formal code, and then might take days of computation. DeepThink just took the natural language problem and worked on it directly. It's a massive leap in autonomous reasoning capability.
Truly astounding. A math Olympiad gold medal. But, as we discussed, there's a catch regarding public access, right? The version you and I might use isn't quite that gold medal winner.
That's right. It's crucial to remember that. The version available to the Google AI Ultra subscribers achieves what Google calls bronze-level performance on the same IMO benchmark. It's faster, more practical for everyday use, but not the absolute peak performer.
So access to the full power gold medal variant is still restricted.
Very restricted, yes. To a small vetted group, mostly researchers. However, it's also worth noting something interesting. Independent researchers using the publicly available Gemini 2.5 Pro model, not even DeepThink, but the base Pro model managed to solve 5 of the 6 IMO 2025 problems too.
Really?
They use sophisticated prompting techniques, like getting the model to verify its own work multiple times, self-verification. It took more effort, more interaction, but it shows the raw reasoning power latent in the base Gemini 2.5 model is already extraordinary.
Wow, so the potential is huge even without the specialized DeepThink layer.
It seems so, yes, which is exciting in itself.
Okay, so stellar math performance. What about other areas? Competitive programming, that's a different kind of reasoning.
It excels there too. It achieved a state-of-the-art score of 87.6% on a benchmark called LiveCode Bench V6. That's the pass at one metric, without using external tools like interpreters.
How does that compare to rivals?
It outperformed OpenAI's O3 model, which scored 83.9%, and xAI's Grok 4, which got 83.2%. So a clear lead in that domain, which involves complex algorithm design and coding under pressure.
Impressive. And then there's this benchmark called Humanity's Last Exam, HLE. Sounds ominous. What's that about?
It's designed to be really hard, resistant to models just memorizing stuff. It tests expert-level knowledge across a huge range of fields: math, physics, biology, humanities, even multimodal problems involving images or data.
Like a super broad PhD qualifying exam.
Kind of, yeah. And DeepThink achieved a score of 34.8%.
Is that good? How do others compare?
It's state-of-the-art, significantly surpassing others. For context, the preview version of Gemini 2.5 Pro scored around 21.6%, Grok was about 25.4%, and OpenAI's O3 got 20.3%. So DeepThink's score indicates a really broad, deep capability across many expert domains.
The numbers are certainly impressive across the board. But beyond benchmarks, what are the early users, the people actually interacting with it, saying? What's the qualitative experience like?
Reports are very positive, especially from researchers and power users. It's seen as a powerful tool for exploration and discovery. While some researchers mention it formulating genuinely novel mathematical conjectures. One even reported it proved a previously unsolved conjecture using a completely new method that hadn't occurred to human mathematicians.
Wow, that's incredible, proving unsolved theorems.
Apparently so. And people like Professor Ethan Mollick at Wharton noted its success on really complex creative coding tasks.
Such as?
He gave it a single prompt to generate a functional 3D Starship control panel interface. DeepThink apparently succeeded where other top models failed completely.
A Starship control panel, seriously.
That was the example. It also seems good at proposing lucid solutions for complex business strategy problems and helping with iterative design work. So it's not just theoretical power, it's proving useful for complex, real-world creative and analytical tasks.
Okay, these capabilities are clearly top tier. Bringing it back to the market, how does this position Google strategically? We know it's a premium feature.
Right. Exclusive to that $249.99 month Google AI Ultra plan with capped usage. The high cost and limits reflect the computational expense we discussed.
And the rollout beyond that?
They plan to expand access via the Gemini API, but starting with trusted testers and enterprise partners. So it's a measured, deliberate rollout, not throwing it open to everyone immediately.
And in the competitive arena, against OpenAI's O-Series, xAI's Grok, how does DeepThink fit?
It's absolutely fierce competition. Google is clearly differentiating DeepThink based on this parallel thinking capability, and very importantly, that IMO gold medal win.
That's a big marketing point.
Huge.
Yeah.
Especially since OpenAI also claimed an internal model got an IMO gold. Google having this verified public benchmark result gives them credible evidence of a performance edge, at least in these complex reasoning domains.
Yeah.
It's a key part of their narrative in this AI battle.
Okay. The power is undeniable, genuinely impressive stuff. But as always with powerful tech, there's the flip side, the risks. What are the downsides here?
You're right to ask. It's a critical point. DeepThink's extraordinary capabilities are directly linked to new kinds of risks. In fact, its development actually triggered Google's internal frontier safety framework evaluation process.
Their system for checking the most powerful models.
Exactly. And the model crossed what they call early warning alert thresholds, specifically for uplift level 1 in CBR and threats. That's chemical, biological, radiological, nuclear.
Meaning?
Meaning the assessment concluded it could potentially significantly aid low-resourced actors in developing weapons of mass destruction.
That's sobering.
It is. It also hit the same warning threshold for cybersecurity risk, potentially helping attackers find or exploit vulnerabilities. The power cuts both ways.
So what's Google doing about these alerts? How do you mitigate that kind of dangerous potential?
Well, Google states they've put robust mitigation strategies in place. This includes things like sophisticated filtering to try and block harmful prompts or outputs, multi-layered monitoring of how the system is used, strict enforcement policies for misuse, and ongoing red teaming.
Red teaming, trying to break it.
Yeah, intentionally probing for weaknesses and potential misuses so they can hopefully patch them before bad actors find them. It's an ongoing process.
Beyond those really serious safety concerns, are there more practical limitations users might run into day to day?
Yes, definitely. One thing noted is that DeepThink apparently has a higher tendency to refuse benign requests compared to the standard Gemini 2.5 Pro model.
Meaning it's overly cautious.
It suggests the safety filters might be quite conservative, sometimes blocking innocent queries if they stray near sensitive topics. It's that difficult balance.
Okay. Any other limitations?
It's still subject to the general problems all large language models face. Things like hallucinations, making stuff up confidently, occasional slowness because of that intense computation. And like most models today, it has a knowledge cutoff date. January 2025 for this one. So for really current information, it still needs to use external tools like search.
So if we step back and look at the big picture, it seems like the very capability that lets it win a math gold medal is precisely what makes it competent enough to trigger these serious safety alerts. It's a real paradox.
It really is, and it signals, I think, a new and much more challenging phase for AI safety.
How so?
The core problem is shifting. It's not just about preventing models from saying offensive things or generating misinformation. Now it's about preventing highly competent models from explaining how to actually execute complex, potentially dangerous, real-world plans or procedures.
And those benign refusals you mentioned.
They're a symptom of this tension, right?
Yeah.
The safety systems are struggling to tell the difference between a user asking about a complex but harmless chemical process for, say, academic reasons, and someone asking for malicious purposes. So they often have to err on the side of saying no. It's a really difficult tightrope to walk.
So summing up then, Gemini Deep Think. It's clearly a landmark achievement for Google, a big strategic bet on this computationally heavy parallel thinking approach.
Right, and the performance on those tough benchmarks really seems to validate the strategy, at least in terms of capability.
But the limited public access, the high cost, and the significant safety risks we've discussed, they really highlight the huge challenges involved in deploying these frontier models responsibly.
Absolutely, and the development of deep think, alongside things like deep research we talked about earlier, points very clearly towards a future of more autonomous, more agentic AI systems.
AI that doesn't just talk, but does things.
Exactly. This kind of deep, multifaceted reasoning is really a fundamental building block needed for AI agents that can then formulate and carry out complex plans in the real world. We're moving towards AIs that act, not just respond.
And that computational brute force strategy, that's likely to just intensify the AI arms race, isn't it? More power, more scale.
It seems unavoidable. Which brings us to the key research frontiers. Where does this need to go next?
What should we, and you listening, be keeping an eye on?
I think there are three huge areas. First, efficiency. Making this kind of deep reasoning much less computationally expensive, reducing the cost, reducing the latency, so it's more practical to deploy widely.
Makes sense. Second,
Guidance, improving the reinforcement learning or finding other ways to guide the model's massive search more intelligently, so it's not just brute force, but smart brute force, finding the promising paths faster, more reliably.
okay. Efficiency and guidance. And the third,
Has to be safety. This is paramount, tackling this challenge of dangerous competence. We need to move beyond just filtering keywords. We need models and systems around them that can better understand user intent, assess the potential downstream consequences of the information they provide. It's a massive research challenge.
yeah. Gemini Deep Think. It feels like it hasn't just set a new bar for AI reasoning. It's also defined this new, super resource-intensive path towards ever more capable systems.
It really proves that with enough compute and smart guidance, an AI can explore a problem space so thoroughly that it starts to mimic and sometimes even beat human creativity and insight in specific areas.
It's undeniably promising, accelerating science, solving complex problems.
Immense potential. But, as we've discussed, it's also a path filled with risk. It demands a matching investment in safety, in ethics, in responsible stewardship from everyone involved, developers, policymakers, users.
So, the final thought for you to ponder, what new kinds of problems do you imagine an AI like DeepThink could solve? Things we haven't even considered yet. And maybe more importantly, what responsibilities do we all share in guiding how this incredibly powerful technology develops?